The uniform distribution is a continuous probability distribution. We will recognize this distribution because all of the values are equally likely over the range of possible outcomes. And because of this, we'll get the rectangular shape. Okay. So some notations and properties that we will use. We will say that X follows a uniform distribution from A to B, where A is the lowest value of the random variable and B is the highest value of the random variable. We can determine directly what the probability density function is. This function will be equal to 1 over B minus A. The mean is also very easily calculated. Mu, the mean, will be equal to A plus B over 2. The variance is also a quick calculation. Sigma squared will be equal to B minus A squared divided by 12. And if you want the standard deviation, then you just have to take the square root of that. But because it is a rectangular distribution, the easiest way for us to calculate, well, not but so when we're calculating the probabilities to the uniform distribution, we're just going to use the area because we have a simple rectangle. Remember, the area of a rectangle is base times height. So let's say that the distribution of arrival times for fire trucks arriving on the scene is uniform with a minimum value of X is equal to 2 minutes and a maximum of 15 minutes after being called. Okay. So let's describe what X is. Well, X is the random variable. It is the amount of time until arrival of the fire trucks, and time will start after being called, after they are called. Okay, so now that we've defined the random variable, the lowest value that this random variable takes on is given here. It has a minimum of 2 minutes, so A will be equal to 2, and a maximum of 15 minutes. B will be equal to 15. So using those values, then we can say X, our random variable, follows a uniform distribution of 2, 5. We can easily calculate the probability density function. F of X is given as 1 over B minus A, which in our case, this is 15. In our case, B was equal to 15. And then we subtract off the value of A. A was given as 2. So F of X will be equal to 1 over 13. This is a horizontal line where Y, or F of X, is equal to 1 over 13. We can calculate the mean. The mean will be given as A plus B, and then we divide that by 2. So A, again, is given as 2. B was 15, we add 2 and 15 and then divide that by 2. So the mean of this distribution will be 17 over 2. The variance is given as sigma squared. Sigma squared is equal to B minus A squared over 12. So we just plug in our values. B was equal to 15 and A was equal to 2. We subtract those, square them, and divide by 2. So we get 13 squared over 12, which is 169 divided by 12. And this is approximately 14.0833. And then to find the standard deviation, remember, we just take the square root of sigma squared. That is the square root of 169 divided by 12. And this is approximately 3.7528. So let's consider the following continuous probability distribution where X follows a uniform distribution in between 1 and 8. So the lowest value is 1, so hence the rectangle starts at 1, and the highest value is given as 8, so the rectangle ends at 8. Right? So what probability is shaded? Well, we just go and look at the box. The lowest value that starts is 2, and the highest value that's shaded is 5. So we are looking for the probability that x goes in between 2 and 5. That is the probability. We'll be back to calculate that in a minute, but that is the probability that is shaded. So what is the height of this continuous uniform probability distribution? Okay, so what is the height of the rectangle? Well, we know this. The height of this rectangle has to be the probability distribution function. We could use that. We also know that the area under this rectangle has to be equal to 1. So let's do it both ways, but we know then that the rectangle as it's given, the entire rectangle starts at 1 and ends at 8. So the base in this case is 8 minus 1, which is equal to 7. Okay. So this length here is 7, the base. Now the area we want to be, area is equal to base times height. It is a probability distribution, so we want the area to be equal to 1. We know the base is 7, so let's solve for the height. We can do that just by dividing by 7, so this height must be 1/7. Now we could have done it using the probability distribution function, and we can do that here as well and see that it's the same thing. So f of x is given as 1 over b minus a, and in this case b was equal, the highest value was 8, the lowest value was 1, so the probability density function is f of x is equal to 1/7. So the height and the PDF of the uniform distribution are the same. Okay, so calculating probabilities with the uniform is very, very easy. Let's just look in general what would happen. So here's a basic rectangle. We know the height of that rectangle is 1 over b minus a because it starts at a and goes to b. So we pick some value in between, we'll call it k, and if we are looking for the probability that x is less than k, we are looking for the area of this rectangle. Okay. So we know this. We know that area is equal to the base times the height. So the area is what we're looking for. The base in this case goes in between a and k. Excuse me. So the base is k minus a, and the height, as always, is 1 over b minus a. And the same thing's going to happen just a little bit differently when we're trying to calculate this area. That is the probability where x is bigger than this constant. The only thing that changes here now is that this is the base, all right? So the area here, again, we'll look at the shaded area of the base times the height. The base now, we take b and we subtract k. That will give us the base of the shaded rectangle, and the height is determined by 1 over b minus a. We can also look for what happens if the probability is going in between two constants. We'll call it k1 and k2. Again, we just need to find this base. The area is the same thing as the probability. It is base times height. So now this base goes in between k1 and k2. So the base is the value of k2 minus k1, and the height stays the same, 1 over b minus a. So back in example 2, we had found that the probability, well, the shaded area was, if we come back up, we were looking for the probability that x goes in between 2 and 5, and that the PDF associated with it was 1/7. Okay, so the probability that x goes in between 2 and 5 And we have the height of this rectangle determined by the PDF, which is 1/7. So this probability is equal to the two n values. So the base will be 5 minus 2. The height will be given by the PDF, which is 1/7. And then we just do the simplification. 5 minus 2 is 3 times the 7th. So the probability in example 2 that x goes in between 2 and 5 is 3/7.